Okay, so we're going to talk a little bit about measurement and uncertainty here today. So first, you've possibly heard it said that physics is an experimental science, and it's usually said by some old dude wearing a white coat or with wild hair or something like that. But it's an experimental science, and so the question is that you should be asking yourself. So what does that mean? And at its most basic level, is that an experimental science is one where observation drives understanding. One of the physics principles you've almost certainly heard of before is conservation of energy. Energy is conserved. How do we know that energy is conserved? Well, we've done a lot of experiments where we've looked at how much energy the system started with, and we looked at how much energy the system ended with, and we looked at how much energy we put into or took away from the system. And when we added all those things together, we found that the energy we started with plus the input is equal to the energy we finished with plus the energy output. So basically, energy in equals energy out, right? We've done this over and over and over again, and it's become a part of the way we understand the world. But that happens with many observations, many experiments. So how do we? So if doing experiments and making observations is a key cornerstone of science, a question directly follows. When do observations disagree? So if you and I measure the same thing and we get slightly different numbers, how close is close enough? And the answer to that is it sometimes depends on the context. For example, in the field of astronomy, oftentimes they're trying to find things like what's the mass of a star. And they're usually happy if you're within about a factor of 2. That's because measuring stellar masses is hard because it's far, far away, and you've got to do a lot of cool things. But that's because it's hard. Then again, when we're talking about what's the width of a hair, and 2 people measure the width of the same hair, well, we really expect them to get it within a few microns, and that is 0.000001 meters, right? So we want them to be within about in this sort of range. 10 to the minus 6 meters. That's what a micron is. So it really depends on the context. So let's see if we can gin up some context on your own that you can try out. So I want you to do a mini experiment. Grab your roommate, grab anybody, and cut yourself a length of string. Make it smaller than a ruler. But long enough so that you could put it into an S shape. Okay? So shorter than a ruler, long enough so that you could put it into an S shape. And then measure its length, and then take it to your roommate and have your roommate measure its length. Take it to your neighbor, have your neighbor measure its length. Get as many people to measure its length as you can, and let's find out if Get as many people to measure its length as you can, and I want you to think, and I want you to be able to answer this question. Do you all agree? And in order to do that, you're going to have to answer, what does agree mean to you? So, coming back to these ideas of measurement and uncertainty, the measurement is the actual value. This is the length of the string. From the previous example. But your uncertainty is sort of, I'll call it your wiggle room. Or sort of helps you create a range of believability. So this tells you, this says, all right, so I think my string is 10 centimeters. Here's 10 centimeters is my measurement. But I would take it, but if somebody said they measured 9.8 centimeter, something between 9.8 centimeters and 10.2 centimeters, this means this is my range. So this means I would report that my length is 10 centimeters, 10.0 if you will. Let me go ahead and write that correctly. 10.0 centimeters plus or minus 0.2 centimeters. If that is what my range of believability is. So measurements are always something that you can calculate. Or directly measure. Uncertainties are things that you have to estimate. So based on the measurement that you made and how well you think you could do it again, that's how you set up an uncertainty. So in the activity coming up on Wednesday here, we're going to have you, I'm going to ask you, given this data for these, we're going to take a measurement 3 times based on our measurements. Is the thing we're interested in changing or not? Does it stay the same or not? Okay. All right. That's all we have for today. Have a good evening. We'll see you soon.